Hello, this is Dr. Armand bringing you another exciting pre-lab video session. In this pre-lab video session, we'll be talking about Lab 9, the last lab, yay, involving the determination of phosphoric acid in soft drinks. This lab's procedure is very similar to the procedure for Lab 8, so there you'll see some similarities in the lab procedure. So sit back, relax, and enjoy the show. So in this lab, we'll be using cuvettes again. We'll be using a 25 milliliter volumetric flask and plastic cups. So in this lab, unlike lab 8, we'll be using a 25 milliliter volumetric flask. And in addition to those, we'll be also using, like last time, a 5 milliliter graduated pipette. And remember, for a 5 milliliter graduated pipette, the pipette bulb is green. And we'll also be using a 2 milliliter graduated pipette. And with a 2 milliliter graduated pipette, the pipette bulb is blue. So make sure you use the right bulb for the right pipette. So for the 5 milliliter graduated pipette, the pipette bulb is green. For a 2 milliliter graduated pipette, the pipette bulb is blue. That's something to remember when doing this experiment. Likewise, we need to wash all the glassware. So again, the cuvettes, the volumetric flasks, the plastic cups, the graduated pipettes. And so we're going to be washing it with HCl, a solution of HCl first, and then we'll wash it with DI water. And the HCl is to help remove any residual phosphates from the cleaning. So first you're going to wash with HCl or rinse with HCl and then rinse with DI water. It's very important you wash all the glassware before starting the experiment. Again, we're washing with HCl first and then DI water. So that's the 2 milliliter graduated pipette. Now we're going to wash the 5 milliliter graduated pipette. Similar type of process. First, the HCl solution. Then we do the DI water. We don't want any HCl in the pipette. We're going to do the same thing with the cups. So first rinse it with HCl solution and then rinse it with DI water. We're going to do this for all 4 cups. Cup number 1. Cup number 2. So always first wash it with HCl or rinse it with HCl and then rinse it with DI water. So now all the cups are clean. So now we're going to wash the volumetric flask and the cuvettes. Again, doing the same thing. We're going to first rinse it with HCl solution and then rinse it with DI water. Very important that we wash everything or rinse everything thoroughly. We don't want any contamination. Again, the blue pipette bulb is for the 2 milliliter volumetric flask. The green pipette bulb is for the 5 milliliter volumetric flask. And even the cuvettes we rinse as well with the HCl solution and the DI water. We'll be using a total of 6 cuvettes. So now everything has been washed. So some of the chemicals we'll be using this molybdate metavanadinate solution. This is going to help give the solution the yellow color. And so you need to get approximately 25 milliliters of this solution. The next thing we'll need is the standardized phosphate solution. So this standardized phosphate solution has a concentration of 6.25 times 10 to the negative 3 molar. Make sure you record this concentration because you're going to need it for your calculations. And so we need approximately 5 milliliters of this solution. And also we'll have a unknown soft drink solution as well. So these are the chemicals we'll be using in this experiment. So when you're getting ready to prepare your solutions, make sure you have a beaker of DI water, a beaker of the, excuse me here, let's get this right. Beaker of DI water, the 5 milliliters of phosphate, and the molybdate metavanadinate solution. So you're going to need these 3 solutions or these 2 solutions in DI water to prepare your 4 standard solutions and your unknown. So to prepare solution 1, we're going to measure out 0.5 milliliters of the standardized the standard phosphate solution. And every solution that we prepare needs 3 milliliters of the molybdate metavanadinate solution. So to measure out the 0.50 milliliters of the standard phosphate solution, we're going to use a 2 milliliter pipette, which the blue pipette bulb goes with that. And so since we're showing you this, it does drip a little bit, but when you're doing this in the lab, you should fill it up to where it says 1.5. Because from here down is 0.5 milliliters or 0.50 milliliters. But since we're showing you, it does drip a little bit, so you have to be quick here. And you want to make sure that it's up to this mark here, the meniscus, the bottom of the meniscus, so that you can add the 0.5 milliliters to the 25 milliliter volumetric flask. So now we're going to add this to the 25 milliliter volumetric flask, and then we're going to use the 5 milliliter pipette to measure the 3 milliliters of molybdate metavanadinate. Now our lab tech is very pedantic, so she's going to try to get precisely 0.5 milliliters. Now she adds it to the 25 milliliter volumetric flask. And then we're going to use the 5 milliliter pipette with the green pipette bulb to measure out 3 milliliters of the molybdate metavanadinate solution. So we need 3 milliliters of this molybdate metavanadinate solution for every dilute solution we prepare. And so to get 3 milliliters, we're going to withdraw enough solution up to the 2 mark on the 5 milliliter pipette so that we know we have 3 milliliters in it. Now, if the solution keeps on dripping, it may be that your pipette bulb is a little loose. You may want to try to make sure it's snug on the pipette. So we're going to add our 3 milliliters of the molybdate metavanadinate solution. This is what gives the solution its yellow color. So it complexes with the phosphate and generates a yellow color so that we can use UV spectroscopy to analyze the concentration of phosphate. And now we're going to fill the rest of the flask with DI water up to the calibration mark. So remember, when you get close to the calibration mark, you want to make sure you use a disposable dropper so that you don't go over the calibration mark. And so it takes about 10 minutes approximately for the yellow color to form. So we're going to set this aside and make the other 3 standard solutions and the unknown solutions so that we give it time for the yellow color to form. And you want to make sure again that the bottom of the meniscus is at the calibration mark. Then we're just going to mix it to make sure that all the solution is properly mixed and pour it into the container labeled number 1. So we just prepared solution 1. So now when we're preparing solution 2, we need to first rinse the volumetric flask with the HCl first, then the DI water to remove any residual phosphate. So now for solution 2, we need 0.75 milliliters of the standard phosphate solution. So again, we use the 2 milliliter pipette to withdraw 0.75 milliliters of the stock solution of phosphate. And so here, 0.75 milliliters, if I can get a good visual of it. So 0.75 milliliters would be, it's hard to see, but it'll be above 1.5. Remember, 1.5 down is 0.5 milliliters. So you would go up 2.5. So 1.75 is where you want the meniscus to be. And we didn't get it in this shot here. So we're going to add that to the volumetric flask. So again, for solution 2, you want to withdraw up to the 1.75 milliliter mark. So you want to fill it up to the 1.75 milliliter mark. That way, when you discharge it, it'll be 0.75 milliliters, because down here is 1.1, 1.2, etc. Anyways, correction, you should withdraw up to the 1.25 milliliter mark, which is 0.75 milliliters. And so, because as you're going up, the tick marks decrease from 1.5, 1.4, 1.3. So you need to withdraw up to the 1.25 milliliter mark. So that's just one correction I had to make. So now we're going to add this to the 25 milliliter volumetric flask. Then using the 5 milliliter pipette, we're going to add our 3 milliliters of molybdate metavanadinate solution. Again, for 3 milliliters, you need it at the 2 milliliter mark. And then we're going to add DI water until we reach the calibration mark on the volumetric flask. So make sure you don't go over the calibration mark, because if you go over, you have to start over. Do it drop by drop until the bottom of the meniscus sits on the calibration mark. Then you're going to cap it, mix it a few times, and then pour it into the cup labeled number 2. So now we've prepared both solution 1 and solution 2. So now we're going to prepare solutions 3 and 4. So for solution 3, we need 1 milliliter of the standard phosphate solution. And again, we're going to rinse our volumetric flask with HCl solution and DI water before we proceed. Now, using the 2 milliliter graduated pipette, we're going to add 1 milliliter of the standard phosphate solution. And so you see here at the 1 milliliter mark. Next, we're going to add the 3 milliliters of the molybdate metavanadinate solution. This is what gives the yellow color of the solution. Again, we need 3 milliliters of it. So we're going to withdraw up to the 2 mil mark. And now we're going to add our DI water. So you want to make sure you add the DI water up to the calibration mark and do not go over the calibration mark. You go over, you got to start over. So as you get closer, you may want to do drop by drop to make sure that the bottom of the meniscus sits on the calibration mark. Then we're going to cap it and mix it a few times. Now we've prepared solution 3. So we're going to pour it into the cup labeled solution 3. Now for solution 4, again, we're going to start by first rinsing our glassware. Now for solution 4, we're going to need 1.25 milliliters of the standard phosphate solution. And then we're going to add it to the volumetric flask. Next, we're going to add our 3 milliliters of the molybdate metavanadinate solution. With the 5 milliliter graduated pipette. And then we're going to add DI water until the bottom of the meniscus of the solution sits right at the bottom of it, sits at the top of the calibration mark. We're going to cap it, mix it a few times, and add it to the cup labeled solution 4. So now all of our solutions, or solutions of known concentration, have been prepared. So now we're getting ready to prepare our unknown solution. So we're going to take 0.5 milliliters of our unknown soft drink. And so again, we're going to start off by first rinsing everything with HCl solution and DI water. So we're going to use the 2 milliliter graduated pipette to prepare the unknown solution. So first we need to rinse the 2 milliliter graduated pipette because we had used it to prepare the dilute standard phosphate solutions. So make sure you do rinse it. It's very important with the HCl and the DI water. So be thorough in your rinsing. You don't want any cross contamination from the previous solutions that you prepared. So now we're going to pour a little bit of the soft drink. And again, this soft drink is flat because we don't want carbonation in the drink because it'll affect its absorbance. So we're going to just come pour out a little bit of the soft drink so we can get our 0.5 milliliters to make our unknown solution. And so as you can see right here, this is 0.5 milliliter mark. So we're going to add that. Then we're going to add our 3 milliliters of the molybdate metavanadinate solution. Try to say that 3 times fast. It's a tongue twister. Now we're using the 5 milliliter graduated pipette to prepare our withdraw our molybdate metavanadinate solution. And now we're going to add DI water to get our 25 milliliters of this solution. Now we will have to prepare a special blank for our unknown because it has the soft drink, the caramel color affects the absorbance. So we're going to have to blank that out. So our blank for our unknown will be different from the blank for our known solutions of known concentration. Notice that the bottom of the meniscus is on top of the calibration mark. Make sure you thoroughly mix this. And then pour it into the plastic cup labeled unknown. So notice here that we put 0.5 milliliters of our unknown solution in a 25 milliliter flask. This has a dilution factor of 50. So whatever we determine our concentration of our unknown is, we're going to have to multiply it by 50 to get the original concentration of phosphate in the soft drink. Because we put 0.5 milliliters in 25 milliliters of solution, so it's a 1 in 50 dilution. So the concentration we get is going to be 1/50th of the original concentration. So that's why once we determine the concentration of our dilute unknown, we have to multiply it by 50, aka the dilution factor, to get the concentration in the original soft drink. So now we're going to prepare our unknown blank. So we're going to do the exact same thing as we did in preparing the unknown, except for the blank, there's no molybdate metavanadinate. So when you're preparing the blank for the unknown, do not add any of the molybdate metavanadinate solution. So you're going to use, for the unknown blank, you're going to use 0.5 milliliters of the unknown. So again, we want to make sure it's at the 0.5 milliliter mark. So just because we're showing you it dropped a little bit, but it should be, you should fill it up to right here, the 0.5 milliliter mark. Just because we're showing you it dropped a little bit. And then we're just going to add DI water to this flask. So again, no molybdate metavanadinate in the unknown blank. So she's showing you, you may get confused. You may want to add the molybdate metavanadinate, but it's no, you just add the DI water. So once you get to the calibration mark, we just mix it, and we're going to pour this into a plastic cup labeled unknown blank. So now we've prepared all of our solutions. We can go to the UV vis spectrometer and record the absorbance of all of these. So that's the unknown blank. So here we're just showing you what all the solutions look like. So there's our unknown blank. Solution 2, solution 3, and solution 4. So we've prepared all the solutions for this experiment. So now we're getting ready to collect our absorbance data. So again, we need to blank the spectrometer first with DI water, because we're going to be checking the dilute solutions. So again, make sure the triangle is in the path of light. So here lambda max is 400 nanometers. We're going to press 0 ABS to blank the sample. And then we're ready to start adding our solutions to the spectrometer and recording the absorbance. So we just added the blank. We're going to add some of solution 1 to a cuvette. Now, if you're using different cuvettes, you don't have to rinse them every time, but if you're using the same cuvette, you should rinse with DI water after each usage. So we're going to add solution 1 and record its absorbance. And the absorbance is 0.30. We do the same thing for solution 2. Place a cuvette with solution 2 in it. We're going to record its absorbance. 0.047. So as you see, as we've added more and more of the standard solution, the absorbance is increasing because there's more concentration of phosphate. For solution 3, For solution 3, we have 0.073 absorbance. And for solution 4, our last of known concentration, 0.100. So now we've prepared, or we've measured the absorbance of all of our solutions of known concentration. Now we're going to do the unknown solution. So for the unknown solution, we got to do the unknown blank first. So we're going to add that first and zero out the absorbance due to the color of the soda. So now we've blanked the absorbance due to the color of the soda. Now we're ready to add the unknown solution and measure its absorbance. So now we take the unknown, place it into the UV via spectrometer, and measure the absorbance. So the absorbance of the unknown is 0.055. So now we're going to do a Beer's law plot and determine the concentration of the unknown. But just to show you how you determine the concentrations of the standard solutions, I'm going to show you one calculation or the dilute phosphate solutions. So we're going to be using M1V1 equals M2V2. Now M1 is given to us on the bottle, 6, or I should say 0.00625 molar. V1, if we're doing solution 1, and that's what we'll do, V1 is 0.50 milliliters. This is for solution 1. V2 is always going to be 25 milliliters. And we're looking for M2. So M2 is going to be the concentration of this solution. So that's our unknown. So what we're going to do is set this up. And now we can solve for M2. And we get 1.25 times 10 to the negative 4 molar. Now, if we want to make this micromolar, then we just need to multiply it by 1,000,000. So we take 1.25 times 10 to the negative 4 times 1 times 10 to the 6 equals 125 micromolar. So that's how you go from molar to micromolar. So this is how you do the calculations to determine the concentration of your known phosphate solution. So now we're going to switch gears and show you a little bit of the graphing of the data for this experiment. So here I've set up my data. I have the stock solution. I have the volume of the stock solution used, the concentration in molarity from the calculation of M1V1 equals M2V2. I have the absorbance, and I have the absorbance of the unknown. So what we want to do here is we want to select these two columns. We're going to do a Beer's law plot, so we want to insert an XY scatter plot. We want to make sure that concentration is on the x-axis, absorbance is on the y-axis, which it is. And so for the y-axis, it's just the unit absorbance. And for the x-axis, if you're using molarity or you're using micromolar, here we're using molarity. So it would be molarity. Yeah. And the chart title, Beer's law plot of, say, phosphate solutions. Make sure your data is not skewed. So here we're missing the, yes. So our x-axis is a little bit skewed to one side, so we can change this. There we go, looks nice. Now we can do a trend line. Now R squared is 0.99. That's very good. We have our trend line equation. Now we can calculate the concentration of our unknown. So remember, our unknown had an absorbance 0.055. So now if we solve for x, 0.055 equals 376x minus 0.0195. So we get 376x equals 0.0745. X equals 1.98 e to the negative 4 molarity. Now remember, this is the dilute unknown. To get the actual unknown concentration, we have to multiply it by our dilution factor. Our dilution factor is 50. So here the concentration of our unknown would be 50 times 1.98 e to the negative 4. 9.91 e to the negative 3. So that's the concentration of our unknown. And that's how you do the data analysis for this lab. So that concludes this last pre-lab video session. In this session, we learned about the procedure involved for the Lab 9 involving the determination of phosphoric acid in soft drinks. We also looked at how do we acquire the absorbance data, and also how do we graph the absorbance data to determine the concentration of the unknown. I hope this video was informative for you and you learned something from it. If you did like the video, always click on the like button at the bottom of the page. And this is the last lab, so I've enjoyed having you over this semester. And this is the last time Dr. Armand is signing off.